Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about LiFi, light fidelity. So let's dive deep into it. So what exactly is the problem? Well, problem is that whole world, as in like almost all 8 billion people need World Wide Web. We all need it. It's not just a luxury anymore. It is important, be it financial transaction, be it healthcare, be it education. It has reached a point where this puppy is important. It's not optional. It's not like, no, it is important. So we need it. And we also need good speed. Now, this is a really bad thing with India, is that we get 4G very early on. Awesome. People get into it. Awesome speed. The moment clients start to join in, as in like more and more customers start to be receiving the SIM and they start to use their phone, the network goes bye-bye. So we'll start on day one, we're like, awesome speed. Day 500, what is speed? We have never heard of this mythical creature. So we not only need connection, we also need good speed. It's not just like, 1 Mbps, 2 Mbps. No, we are in a point where 100 Mbps is good. Now, be mindful, can we achieve most of these things with old technology? Absolutely. If we had true 50 Mbps stable connection on 4G, be mindful, 4G's theoretical limit is 100. So I'm not even talking 100% of its full power. I'm talking just 50% capacity. That's more than good enough, especially if it's stable, as in its ping is stable, jitter is stable, and connection reliability is good enough. People are like, shut up, take my money. That's more than good enough, but nobody gets it. And then if you have 1 Gbps at this point in time in humanity, that's more than good enough for any individual, more than good enough for even small to medium business sizes. So that's really good. This is the target that we are aiming for. You are not longer aiming for the bare minimum. We are aiming for at least something that you can truly experiment with. Now, numbers of users are growing. For example, this is like an old India's graph where we had like year 2000 barely had any amount of people on internet. Now, be mindful, India is the world's largest population country, so even 1% is huge. Now, this only goes to 2017, but in 2022, India crossed a milestone where we have literally crossed 45% of people in India, whole of India, have internet access. That's bonkers. That's like more than US population, whole of it. So ludicrously large amount of people are now online. Now here's the problem. We still have half left and we are still our rate is very good. So we still have some serious room to go. So that simply means our number of users, that is huge now, will become even more huge. So we are growing exponentially and all of them, they need it. It's no longer just like, back in the day, if I had net, it's a good thing. If you don't have it, it's minor income. No. Now it could cause harm. So fundamentally, we all need it. Now, biggest issue is that this sort of image that you see, like, oh, we're going to have 5G, we're going to have this speed. Problem is, this will be true only as long as tower is unsaturated. The moment tower gets saturated, tower is like, bro, you have to understand this. My connection link speed is more than good enough. That's not an issue. Is the fiber that I have that is going back to the base, quote unquote, that's only a very small pipe. It could be as small as 10 Gbps. So if they actually give 1 Gbps connection to 10 people, they are already at saturation, meaning 11th person joins in, everybody starts losing speed. Now, all mobile companies, they oversaturate to like 300 to 400%. Now, thankfully, mobile networks are designed in such a way that can handle it, but consequences, your speed becomes bye-bye. So that's why we never got true 4G speed. Like none of you, unless you live in some very unique place where you have very few people and like all mobile towers are undersaturated, most of the time you will have, isn't this puppy supposed to give me 100 Mbps? Why the heck I'm barely getting 10 Mbps? And let alone reliability. Oof, good luck with that. And same will happen with 5G. So if you must have seen that meme image that there is a small pipe, 3G, and you have little water coming out. Big pipe, 4G, little water coming out. 5G, huge pipe, still little water coming out. That's the reason, is the link speed from your mobile phone to your tower, that's getting fatter and fatter, no problem. Is the fiber link backbone, that's still limited. So that's the issue. And we cannot upgrade it. So if we really want to give everybody 100 Mbps reliable speed, flat out we cannot do that. Our infrastructure cannot keep up. And if we truly try to, just lay fiber in, like just go all in with fiber, it's prohibitively expensive. It's the best solution, but it's prohibitively expensive, meaning you're going to go bonkers in bankruptcy if you try to do that right now. If we had proper growth strategies on day one, it would not have been an issue, but such is life. So this is the issue that we are facing right now. So what is our current solution? Current solution, as we all know, fiber is awesome. Now, why fiber is awesome? Because it runs at almost the speed of light. Now, be mindful, if you compare the distance, you'll always find fiber to be lagging, simply because fiber does not have like one laser directly going one way. It's like it's bouncing around a lot. Now, of course, multi-mode has really bad, single mode still has few bounds. So if you calculate the bounce distance, it's fundamentally longer. So you may be like, hey, it's 300 kilometer, but from laser's vantage point of view, it could be 400 kilometers. So it's fundamentally slower. So that's why we can only say almost speed of light. It's not light speed, almost close to that. The true light speed would be only between Starlink satellite, because A, absolutely straight, B, almost nothing in between. So that will be the point where we'll have true light speed communication. And this puppy is stable. Now, this is very important aspect. As we switched our financial transaction to electronic transactions, we need accuracy, and that accuracy requires clocks. Those clocks requires stable connection, meaning you cannot have jitter, you cannot have ping going ups and down. That's a very dangerous thing for a company to do, or any corporation or any banks to risk. So if you see your ATM, generally they have a very good hard line. Now, that hard line does not need to be like 100 Mbps or something like that, but it needs to be stable, it needs to be verified, it needs to be absolute, like it's there, it's on, and it's not going, it's absolute. So fiber does that. That's awesome. Now, laying down fiber is expensive, like very, very expensive. Now, you may ask, like, is fiber technology really that complex? Hell no, we had this technology in 1970. So fiber itself is cheap, not even expensive. Like, I'm not even joking. But problem is the bureaucracy, meaning to do this sort of thing, you need to get what we call permits. Now, many permits are logical in principle. In real world use, you could literally be in India, you can have permission from central government, you can have permission from state government, but the regional head office officer could be like, lol, I don't give it up. And now you can spend months just to get the goddamn permit. Many of the India's metropolis have very high population density. So people wanted to, like, of course, every company would be like, hey, I want my customer to be happy, so they give me more money. So they're like, what if we have more fiber interconnects between towers, so towers can actually handle more customers? Awesome. They tried to do that, and like, nope, will not allows you to do this. Even nowadays, we have the better technology. Instead of doing trenches, we have what we call basically vertical drilling, horizontal drilling. We are drilling like this. Now, again, that also requires permit, and cities might be like, again, there is another aspect of it, that there may be sewer lines, there will be other optical lines, there may be other communication things, gas pipelines, all that. So it's not just like, don't think about it. It is a tangibly complex thing. But all of this hassle create a scenario where you literally are choked by the bureaucracy, not choked by the, oh, technology is not there, oh, it's taking too much time. It's just like, it costs around 1 crore rupees. That's a lot of money. That's like, unless you are buying supercar, nothing goes to that kind of price. Super duper expensive per kilometer. Now, is fiber really that expensive? Hell no. Is the machine that you are buying, you can, instead of renting the machine, you can buy the machine and you still have money left. What about the people? Same thing. But then why the heck it's so expensive? Is the bureaucracy. Because you may be paying all these people for months, even though they are not working. So bureaucracy is seriously frustrating for every company to deal with. And permits you have to do that before you start. So you cannot even plot out your route. You have to plot out multiple routes, hope that you know which route you're gonna get, and plot out all the work access, worksheets, and fiber requirements. So yeah, good luck with that. So that creates a very serious, like, this is Google's micro trenching technology they wanted to try. And again, it could have worked, but they did not do it properly. So backfired. So cost per kilometer is so high that it's just stupid, and it does not need to be. Let that be very clear. Every technology in it is basic. Everything in there is just basic. So right now, how do we solve it? We use these puppy. These are what we call wireless backhauls, meaning they have giant 5G systems, and they communicate to another pole that would be something like this, huge, and have huge dish. They are acting as a basically wireless backhaul. It does work. Now, is it as awesome as fiber? Hell no. But fibers, because of the bureaucracy, because of the hassle involved into it, people are like, dude, this is just cheaper. And especially if you're going through mountainous terrain, this becomes far more economically viable also. So that's our current solution. We have fiber, or we have super expensive, hyper huge, wireless backbones, which are, it does work, but expensive, meaning you will never build this puppy where you have small communities. You will like, no sir, you cannot have enough customers to, take care of that cost. So here comes light fidelity. So the idea with light fidelity, many times people say it uses optical spectrum. Hell no, it does not use anything that human can see. Most of the time it's infrared or ultraviolet. 99% of the time it will be infrared. Now the reason you do not want to use the optical spectrum is simply because humans can see it. You do not want your city to light up like disco light when it's raining or it's fogging. So fundamentally, you do not want to use optical lasers. And you only use infrared system. Now, why the heck you want to switch from radio waves to this puppy? Now, this is where we come to the physics level. The best core aspect of physics is that laser beams are inherently coherent, meaning if I give you 10 watt of output power, like 10 watts of photons are same in basically, you are talking about infrared, you are talking about ultraviolet, you are talking about optical, or you are talking microwave. Photons is a photon, it's just the wavelength is different. So if I give you the same amount of oomph, like here's the 10 watt oomph that you're sending out, how far microwaves can go while still remaining coherent enough and still have like, signal to noise ratio clean enough where it can be discerned, versus laser. Laser is like, bro, I get this. Laser is fundamentally much more longer range, like it's so huge. Like if you had a transmitter, like the best transmitter, you can launch a signal from basically Mars, and by the time it reaches Earth, it will be larger than the Earth's diameter. That's the best laser we can build for microwave. If you did that with optical spectrum or infrared, that laser spectrum would be like a very tiny small size. I mean, like it still would be huge. It's like the size of America, but size of America versus size of the planet Earth. So you see that these are on the law of physics level, meaning it's the inherent benefit of using optical spectrum, basically higher frequency than basically infrared, or like, low infrared, so to say. So distance with less power, that's the physics level aspect of it. Radio waves are not coherent, meaning these sort of 5G backhauls, they do work. That's why we are using them, but these are idiotically expensive, power hungry puppies, and they are not something that you can just like twing. It's brutal, and not to mention, it requires you to have enough demand to justify the cost of it. So that creates a very serious issue. So if you take this, yeet all the radio wave system, replace this with infrared optical system, you'll be like, shut up, take money, the end. So light fidelity is one of the greatest technology we have for point-to-point backhaul communication. Is it as stable as fiber? Hell no. Is it exponentially cheaper? Undeniably so. So there is some serious interest there now. However, be mindful, some people smoke too much weed and they thought like this could actually replace Wi-Fi. Now, the first idea that was hyper stupid is like, we're gonna use the LEDs as a blinking device and it's gonna transmit the signal. I'm like, what if you have to turn off the light? We're gonna have an extra device that's gonna blink in infrared and that's gonna communicate. It's like, if you need to have an infrared device, why not just use that infrared device? They're like, yeah, that makes sense. It's like, why tamper with electrical system if you don't need to? If you're like, hey, lights, normal lights, don't think too much about it. Why the heck you want to tamper with it? It's like, yeah, it makes sense. Okay, I'm gonna make an independent infrared system. Now you're like, if you're as old as I am, as in like 30 years, you must have remembered we used to have phones that had infrared before we had Bluetooth. It does not work. It's a line of sight communication. It does not work as reliably as you may think. That's why we don't use it. So this sort of idea of laptop's gonna have an infrared receiver, or mobile is gonna have this sort of receiver, it does not work, because if you cover your mobile phone or your mobile phone is in pocket, you're not gonna get your WhatsApp message. If you're not gonna get any connection, simply because, hey, line of sight, it has to be line of sight. So fundamentally, we like Wi-Fi because it's convenient. It's like very convenient. Now some people say, what about security? Here's the deal. If you are really working in military installation, you will not have a wireless communication. That's the first rule. Every communication has to be hardwired. Heck, the submarines, US submarines, the communication line inside them is freaking fiber optic, which I never understood why the heck. But then like, what if one of the soldier is a spy and he can tap into electrical system far easier compared to a fiber system? So I'm like, yeah, it kind of makes sense, especially when you're talking about some serious code, some serious spicy codes. So that's why do not expect this puppy to ever replace Wi-Fi. It's like inherently inferior than what we have. And everybody's like, oh, Wi-Fi only goes to 100 Mbps. I'm like, how long ago Wi-Fi you are trying? Like Wi-Fi that you can buy in modern mobile phone with model, like unless it's like super cut down budget mobile phone, you will get 200, 500 or maybe even gigabit speed on your Wi-Fi nowadays. So I have no idea. It's like, it's not even a speed benefit, and it will work in your pocket. So light fidelity, awesome technology for what we call point-to-point backhaul, super useless for Wi-Fi. So do not expect these things to work. That's why like the first time I converted this technology, it's like, dude, did nobody remember the history? We had that, it does not work. So what are some limits of this technology? Now this is Google's approach. Google tried it and this is deployed in India, linked a video down below. You have to understand there is some laws when you're talking about lasers, and every country that has brains and has people and has laws generally have a law about it, that thou shall not have too much laser power just in free floating air. Like you can have laser power inside a metal laser cutting, go YOLO on it, but if you are exposing humans to lasers, that laser has to be very low power. For example, laser disco lights and all that jazz, it has to be very, very low power. So the idea with that system is that no matter what happens, even if you have a reflection, it should not instantaneously whoosh your eyes. Like, let alone skin. If it can damage your skin, it's like they're gonna fire a missile up your ass. But it's like, even with your eyes, it should give your eyes a fighting chance to, like, you cover it and hopefully your eyelids will get burned rather than your eye retina. Of course, you may have a spot damage in your retina rather than going blind. So there are some requirements. You will never have a scenario where it's like 100 of watt of laser power. You're never going to do that, like flat out by law. And on top of that, you really do not want a scenario where if birds fly by, it's like poof, it will literally look like, from a bird's point of view, that it flew literally through a soldering iron. So it's really not a good idea that to have very high power. So if you have to work inside the limited power budget, now it's no longer as impressive as you might think. The power budget, the law limitation, it's very frustrating. All cameramen know that, like all of our camera back in the day used to have 30-minute recording limit because European Union smoked weed. So it's one of those things. Now it does need stabilization. Be mindful. You may look at a building, you may look at a tower at a building that looks big, huge, awesome. But if you put a sensitive gyroscope on there or accelerometer, it's going to be vibrating like this, like a lot. So every laser system has this puppy, what we call basically galvanometers, mirrors. So these mirrors are moving in X and Y, and they are very fast, very agile, and they allow you to scan lasers on a much larger area. Benefit of that, now you can target lock. And you have to do this. You may see, like, from your point of view, it will be perfectly stable, but from a laser point of view, and be mindful, as you increase the distance, this system becomes the bottleneck. Meaning you can, in principle, send laser to, let's say, 5 kilometers. Let's say you are on top of a mountain and you can send a signal 5 kilometers away, and there is a receiver there. Problem would be to keep that laser locked there would be very, very difficult. That coherence that made it so pinpoint, it becomes a hassle. In radio, that's not an issue because, again, the beam inherently spreads out. As long as you can discern it, you're good. Here, you will miss it. So for that reason, all the systems that are being in deployment, they have giant mirrors that can correct it. All these Google systems and everyone else who's working on it, like, you have to have a good optical correction system. Otherwise, it will simply not work. So first, you have power limitation because of the law. Second, you have to have very good aiming system, trajectory calculation and all that jazz. And then we have to the final problem. With all these two constraints, the final constraint is the atmospheric transmission, basically how much oomph you can send from here and it will go there while having clear signal to noise ratio. That's limited by the atmosphere, meaning if you have still atmosphere, not too much dust, it's not too much windy, laser signal will be like 10 Gbps, baby. It's like awesome, super awesome. Signal A to B, done, go home, sweet dreams. Now you have kohra, or what we call fog. This sort of thing, yeah, that transmission will go down to 5. Then you're like, hey, what about some rain? Yeah, it may go down to dead. Like, connection will literally fail. So you have to understand, these sort of systems are not as foolproof as a fiber link. Fiber link is stable. It's like, bro, I put it there. There is almost nothing other than landslide that can break a fiber link. Like, of course, if somebody intentionally does that, that's a different thing. But if you are talking about just a natural thing, landslide or earthquake, removing those things, flooding has no effect on it. Lightning strike has no effect on it. Almost nothing affects it. So let alone atmosphere. So this is one of those serious limitations of it. So do not expect this technology to magically replace all our problems. It's awesome, but does have some limitation. So what we can expect in the future? This video became viral recently. Now, it's not a replacement for fiber link. Let this be very clear. Is this good? Yes. Is this awesome? Yes. Is it like fiber replacement? Hell no. Meaning you're gonna go to any stock exchange, we're gonna give you this laser, they're like, disappear. So fundamentally speaking, it's a good add-on to fiber link. Meaning, let's take an example of a Mumbai or capital cities, Delhi. This sort of scenario, you have basically city exchange. Lot of fiber links come there and then it distributes around the city. Now, city already has a lot of fiber link, but they are saturated. Lot of people, lot of high-speed devices, it's saturated. What can you do? In those sort of time, you can be like, from your basically fiber headquarter, you can spread over laser. Now, fiber will always be a backbone in case links fail. But if you have, let's say, 10 physical fiber going, 10 air lasers going, then you can have like twice the capacity. And again, you can even increase the capacity as much as you want. So whenever you have a failure, be it weather related or something like that, link speed will go down for everyone. But when you do have good weather, let's say 80% uptime, 80% of the time people will be like, hey, my system is awesome. So it's a really good way to increase throughput of an existing system. Then what can we expect in the future? Well, NASA is working on this puppy, which we call XCOM. They already flown this puppy into ISIS, and they are testing this, basically this puppy. So the idea is that we have X-ray. That's most awesome scenario. Why? It does not give you cancer directly. Second, it can go through things, meaning you have things, it can just go through things. So X-ray has that benefit, meaning it does not have that energy limitation that optical side. Of course, still limited. You cannot be like, oh, I put my hand in front of the laser beam, it literally burned through my hand. No, of course not that much, but it does have a bit more leeway. Like same way we have a microwave transmitter that could be like few kilowatts. You can have an X-ray laser that could be like let's say 100 watts. That flat out will be exponentially more powerful, more far reaching, and because of the fact the wavelength, it inherently is far more resilient to almost everything. If a plane goes through it, no, if nothing happens. If a person goes through it, nothing happens unless they stay there forever. So it's one of those things that that's the final solution. And why NASA is working on it? Because you have to understand there is an issue whenever you have any re-entry vehicle, anything, be it a Dragon capsule or old space shuttle, they go through Earth's atmosphere at super high speed. Consequence, plasma wall builds around it. Consequence, no radio wave can penetrate plasma. So they are in what we call radio silence. You have nothing, no communication. So if you have X-ray, X-ray can just punch through plasma wall. And the military also loves this idea. Why? Because that's how you basically communicate to a hypersonic missile. Hypersonic missile traveling at hyper speeds and going through the atmosphere creates a plasma wall. Radar cannot lock onto it, but consequence, you cannot communicate using radio waves. So you need this puppy in order to maintain the communication. So X-ray is the future system, and X-ray in principle can give you almost same uptime as fiber links, meaning at that point in time fiber would be there is not tangibly a good reason. Right now there is a lot of good reason, it's just that you do not have the money for it, like, which is a truly great tragedy for the great nation of United States of America. Because again, American politicians, surprisingly, a lot of them had goodwills, and they were like, hey, we know the private companies are private, they only work for profit. Awesome, got it, super awesome. Problem is that if we have this sort of area where we have a lot of small counties, we have very few people, they will never get internet, they will never be put online, quote unquote. So what if we give these companies capital cost to build the fiber link, and then they can earn profit from that? We spend a little bit of tax, they get a fiber link, and everybody wins. Awesome. This has been going on for decades, not 1 year, not decades. So what happened to that money? Not politicians, telecommunication operators. Like, there should not be any need for SpaceX to exist in such a way where they are building Starlink for American audience. That should not have been. The amount of money they have burnt, it's in billions. Meaning, if you like, and for the distance, they would be like, dude, 1 fiber link, 2 fiber link, 3 fiber link, 4 fiber link. 100% of America should have like good, high quality fiber link to every remote community. Every single one of them. They're like, dude, we got fiber for days. That's how much money US burnt. So that's why this sort of option is secondary option for that. Like, it's more of like community kind of project, where there's like community is like, dude, companies are trolling. This guy did that. It's like there was a company that was like GeoFiber that was like, hey, we cannot jump through this mountain. So this individual is like, what if we give you the tools for it? They built the tool, very low cost, very efficient, and voila. Because small regions are the one that is getting affected. Right now, India is going through some good growing phase. We have fiber to the home directly at very low cost. Like, heck, even my internet, again, it's not very awesome, but it's like 300 Mbps up and down, and I have around 3.2 terabytes of capacity, as in like the bandwidth cap. So we are getting through some serious horsepower, but again, it will reach a saturation point where the backbone fiber would be like, bro, can't scale it up more. So that's a serious point. Unless we go to X-ray, this sort of system will not be like the final backbone. And current systems are very awesome, like this puppy is very awesome for what we call last mile, meaning fiber link, undersea fiber, awesome. Undersea fiber to national fiber, awesome. National fiber to the state fiber, awesome. State fiber to the district fiber network, awesome. From there, we have no idea, like, what the hell we to do after that. So from their point of view, to like, the mobile tower near you, it's awesome. For that, it's like shut up, take money. For places that have like one location that is coming close to that and then jumping the mountain, because again, there is a small community there, boom, awesome for that. So last mile, remote locations, it's super duper awesome technology. For that niche case, do not expect this to replace Wi-Fi. That will not happen. So this is what we can expect in the future. I really like the name XCOM. So this was my presentation on basically light fidelity. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.